Hi, ladies and gentlemen. So this is the calculation we did during class on Wednesday. You guys measured and put in your voltage and your measurements of your resistors. Okay. So what we're going to do here is we're going to go back in and make this on the computer and get our value for our real amperage, so we can decide what our LED ohms actually is, okay? So what I have so far is I have this calculation, so I have my total resistance, I have my total amperage for the whole system, and then I have my voltage drop at each resistor. And then added up, this is the total voltage. It should equal close to what your original voltage was. So ignore this number. I did a little practice thing here so I could show you. But what I'm going to do is I'm going to stop. I'm going to switch my screen. And this is our little circuit that we're going to build in Tinkercad. Okay, so I'm just going to do this real quick for you. I'm going to go to Tinkercad. Okay, Tinkercad. We're going to go into our website, or into their website, and if I log out here real quick, it's pretty crazy that Tinkercad's owned by Autodesk, which is the same as Inventor, but it's a really simple program to do simple shapes and stuff like that. I'm going to go to sign in, and I'm going to sign in with Google. I'm almost 100% sure you can do that yourself, and you might have to log in and everything, but I'm already logged into my Google account, so it should automatically go in. But you're going to go over here to circuits. This 3D design is how you do these silly little designs, whatever. It's as simple as it comes. But I'm going to go back to Tinkercad here and go to circuits. Okay, so here's just a bunch of circuits that I made as a practice. I'm going to do this really fast just so you guys get an idea of how this works. You can search for things. You can change this from basic to advanced. I'm just going to choose all of these. I want a breadboard. Okay, so we're going to do it. I'm going to do it. You know what? We could even do a mini one. A mini breadboard. We can do, if you come back here and you do battery, here's our battery, boopity boop, and I'll zoom in here just so you can see. I'm going to do a resistor, and we'll place a resistor in here. You can come up here and flip it, okay, and we'll go boop, just like this. We'll go, because we need two resistors, and boop. And then our push button switch, I'm just going to type in, it's right there, but if it doesn't show up, you can hit push button switch. You can type in LED and LED. Okay, that's all the things that I need for this circuit. Okay, it's pretty simple. So I'm going to take and I'm going to go from positive to here, from negative to here, and it even lights it up to make it easier for you. It's pretty nice. You can also select, like this is supposed to be positive, so I'll select red. I'll make this black. Kind of neat, You can drag it around and make it easier to see if you need to. And then you can also do a note. So I could say, Mr. Raggi made this. I don't know, whatever. So, okay. So what I'm going to do now is I'm going to come up here to Start Simulation, and I'm going to go beep, 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 and right now I've got 1 kilo ohms, or 1,000 ohms, 1,000 ohms. That's not what I have as my object. So I'm going to say 100, and I'm going to say 10. And if you did it right, it should be brown, black, brown, brown, black, black. Okay, and if you rotate it over, it would be the other way around, whatever. Okay, so now I go beep, and now it actually gives me an error, and it says current through the LED is 59.5 milliamps, and its its ideal is 20 milliamps. So it's just saying that it's not going to last as long. So 59.5. So I'm going to come down. Let's switch back to here, okay? And I wrote this down. Total amperage is 59.5, or basically 0.055 amps. I should have said amps. Okay, so total amperage or total current, TC, total current is 0.05 amps, and it does make a difference to make it into amps instead of milliamps because it works better for your calculation. So now what we're going to do is we're just going to go backwards. Okay, so we want to figure out voltage, and then what we can do is we can subtract it from here, and then we can figure out what our ohms are for our LED. Okay, so I'm going to start with this. I'll start with, let's say we have we need to figure out this backwards. So we want to figure out voltage. So we're going to multiply this times resistance. Okay, so I'm going to say voltage at R1 equals, voltage at R1 equals, and we're going to say I'll just make this simpler. 0.0595 amps times, let's say 100 ohms equals, and then equals, what is this, 5.95 ohms, or volts, excuse me. So then V at R2 equals 0.0595 amps times 10 equals 0.0595 volts. Okay, so what we're going to do is we're going to add these up, and we'll what is the, let's see here, 6.54 volts. Okay, so now we'll say 9 volts minus 6.545. Okay, pretty simple. So 3, let's see here, hold on a second. This equals 2.455 volts. Okay, so now I need to figure out the resistance, and whatever resistance is going to tell me what my LED equals. Okay, so I have voltage equals current times resistance, so I can say V divided by I equals resistance. Okay, so what I have, my voltage is going to be this, and this is going to be my amperage. Okay, so for my resistance for the LED, it's simply going to be 2.455 volts divided by 0.0595 amps. Okay, and I'm going to hit pause so I can do the calculate. So my information for my LED, this specific LED, is 41.2605 ohms. So this is what's really neat here. Okay, no matter what your ohms are for this, like what your personal measurement is, this personal measurement, so if this was 0.97 or 97 ohms, and this was 11 ohms or 10.5 ohms, and this was 8.6 volts, no matter what those values are, you're going to come up with 41.2605 ohms, no matter what. And what I want you to see is if I go back to Tinkercad, and I'm just going to do this real quick. I go back to Tinkercad, and I'm going to change this to 97, and I think I can change, I can't change my 9-volt battery, so that'll stay the same. But if I change this to 10.5 ohms, and it should give me this, 10.5 ohms, you'll see when I hit my button here, and I go up here, do you see that milliamp range is different? So if I put that number back in to this system, I'm going to always come up with 41.2605 ohms, no matter what. It's really, really neat. So that's how you find the ohms, and then you could go back in and come up with your actual numbers, because the numbers that we are based on my current, I should switch back to here. All of our numbers are based on this estimation that I gave here. So all of these numbers and all of these voltages will be different. But once you do it backwards and you have that real amperage, you can figure out what the ohms of your LED is, put it back into the system, and you can come up with, you will always come up with this 9 volts that matches this, but these numbers will be changed. Okay? That is the experiment I would like for you to do. So please try and do it so you can come up with this number, and then pump this back into here. So you'll do a full, all new calculation on a new sheet based on, you'll have to leave it at 9 volts because you can't change this with the computer. But then you can change these to your calculations or your whatever, your measurements, and put it back into the system. Okay? That is the number that you should come up with for your value for the ohms or resistance of this LED. The LED in Tinkercad, not the ones that you have on your system. We would, if we, were testing it, and you're welcome to, you would use a ammeter to figure out how many amps were in your system. Okay? Good, good, good.